So to get started with our own generics, here below the commented out code, I will start with a generic function. You can build generic classes and functions, I'll show both, and here I'll start with a function. Now let's say we want to have a function which basically merges two objects and returns a new object. So here we could name it merge, and we want to get object A and object B as an input. Now of course we could write this function in a certain way. We could say this is of type object, and this is of type object. And then what this function does is it returns the result of object assign, where I get object A and object B. So of course, since we got this object assign method already built into normal JavaScript, we could argue if we really need a merge function, but of course you could be doing additional work here. You could enrich this with extra information, with extra options, and in the end this is just a demo, just an example. So this would be valid. We could call merge here and console log its result, like this, and then pass in an object which has a name key, and a second object which has a age. And if we run that and we save this, here in the browser, indeed, we get this output, so we get this merged object. Now, this works. The problem we have with that is if we try to store this, merge name max and age 30, if we try to store this here, I can't access name on the result, I can't access age on the results on this merged object, even though we know that both will exist, because TypeScript doesn't know this. TypeScript can't know this, because we are just telling it you're getting an object, and in the end TypeScript infers that we return an object, which is correct, but which doesn't carry all the information we could use here. Now of course we can always do typecasting. We can tell TypeScript that what we get back is an object where we have a name key and where we have an age key, but that's really cumbersome if we have to do that. So here, generics can help us. We turn this into a generic function by adding these angle brackets after the function name, and then we define two identifiers. Typically you start with T for type, but you could use any identifier here. Doesn't have to be a single character, but the convention is to use a single character, and typically if you only have one generic type, you name this T. And then you say, well, this generic type here, this is now available inside of this function. So we could say what we get here is of type T. Looks strange. We'll get there, no worries. Now here we get two arguments where we don't know exactly how they will look like. So I will accept a second generic type here, simply by adding a comma in the angle brackets, and then we just continue in the alphabet, and therefore the second generic parameter or type you might be using in a function typically is named U. So we could say this is of type U. Okay, now what does this yield us? Well, a lot actually. As you see with this alone, if you hover over merge, TypeScript infers that this function returns the intersection of T and U. And we could of course also set this explicitly like this, but we don't even need to do that because object assign returns an intersection, and therefore since we return the result of object assign, TypeScript automatically understands that this function returns the intersection. So how is this helpful then? Well, if we now hover over merged object, we see that now with this alone, TypeScript understands that what we store in merged object is the intersection of these two object types. Because it sees that we're passing in these objects, which are of these object types it infers, name string and age number, and that our function returns the intersection. Why is it able to infer this now and not with object, which we had before? Because object is a highly unspecific type. We say any object, and yes, therefore TypeScript is able to infer that we return the intersection of object and object. But the intersection of two unknown objects is just a new unknown object, which doesn't offer any additional type information to TypeScript. With generic types, what we're telling TypeScript is that these two parameters can and often will be of different types. And therefore, TypeScript is able to understand that we're not just working with some random object type, but that we will get different type data here, and that this function overall will return the intersection of that data. And therefore, TypeScript is able to understand that what we store in here in merged object is such intersected data of these two inputs, because now we're not just dealing with some unknown objects here, but with very specific types. And therefore, now if I console log merged object age here, this works without errors, as you can tell. Here I'm printing 30 because of generic types. We're giving TypeScript the extra information that we don't know what exactly the types will be. Sure, there will be objects here, we can tell that, but we don't know if it's an object with a name key, with a age key, with a hobbies key. We don't know, and we don't care. We don't care about the exact object here. We don't want to specify that this has to be of this type, because then all of a sudden, if I had hobbies in there, we would have a problem. So I don't want to be that restrictive. I just want to say this is of any type, which I don't care about, but it's most likely a different type than this one here. And if it would be the same, that would be fine too. But TypeScript understands that we do have specific types here for these two parameters, and that we return the intersection of them, instead of just having any unspecific object here. Now, specifically, the magic here is not just that we tell TypeScript that we got two different types here, but that these types are not set in stone when we define this function, but they are set dynamically when we call the function. So here we're calling the function, and TypeScript infers the types for the two arguments. For t, it basically fills in an object type with an object with a name property, which holds a string, and a hobbies property, which holds an array of strings. And for u, it fills in a type of type object with the age property, where age is of type number. Now, when we call this function again in another line and we pass in different objects, and I store this in a new constant with a new name, then of course different types are filled in for t and u for this function call. You can also specifically tell TypeScript which types it should fill in by adding angle brackets after the function name when you call it, and then you would fill in your own types for t and u. We could tell TypeScript that t should be of type string for this function call, and u should be of type number, but then of course TypeScript would complain about the concrete values we're passing in here, because this clearly is not a string, and if we would fix this, this clearly would not be of type number. So here we could be very specific and say, well, the first argument, or the type t to be precise for this function call here, will be an object type, where we have a name property, which is of type string, and a hobbies property, which is of type string array. And the concrete type for u for this function call will be an object where we have a age property, which should be of type number. And now we would be good and no errors would be there anymore, and this would work, but this is redundant. You can absolutely do that, and it is important to understand that this is in the end what generics are all about, that you can fill in different concrete types for different function calls, but we don't need to do that here because TypeScript simply infers the types of the values we're passing as arguments here, and then it plugs in the inferred types for t and u for this function call. That's how generics work behind the scenes in the end.